Okay, I've shown you how to do the first part of this linear regression project, which was displaying your data on a graph, finding the equation that you think is the line of best fit for the data, where you're just guessing or using some common sense to figure out which one splits the data. This is how to find the actual calculated least squares regression. This looks a lot uglier than it is. The actual calculated least squares regression line comes from the sum of all the squared vertical distances between each point in the best line of best fit. So you're basically squaring the distance between each of these lines and some more. That's a very simplified version of what's happening to see what you're pretty much looking for the average distance between all the points to be zero, all the average distance from the points on top of the line to be the same as the average distance of all the points on the bottom of the line, so that your line goes right through the center of the data. Okay, this equation right here is not that surprising. Everybody gets confused. Y prime equals a plus bx. This a is your y-intercept and b is the slope. This is the equation y equals mx plus b. The only difference is here is that you have y, you start with y equals mx plus b. That's what you're used to seeing. But then what if you were to reverse that and say y equals b plus mx, right? It's still this, same thing, correct? Now we're going to say y equals a. So we'll change the b to an a, and we're going to change the m to a bx. So there's your equation. So this is the y-intercept, this is the slope. This equation is a linear equation. It's this equation right here. We've just changed the names of the variables and reversed it so the y-intercept comes first and then you have your slope after that. And this, to me, this makes more sense. If you're thinking of a linear equation, you have your y-intercept is where you start and then you add your slope. Points on your slope. So it actually makes more sense to me to write the y-intercept first and then to add your slope to it. People, when I've explained this to students that are confused, this always clicks, whereas the mx plus b form doesn't necessarily show them what they need. So you start with the point A, the y-intercept is your starting point, and then you add slope values as you go, or the rise over run. You keep going rise over run to get the rest of your line. Okay, n is the number of data sets. In this case, my n is 10. I have 10 xy data points. In Greek, the symbol epsilon means sum. So when you see epsilon x, that simply means sum the x values. Epsilon, this is sum x. That's all that means. It looks fancy, and you see this in all these movies where people have the summation sign behind them. That's really not that complicated. That's literally all you're looking at. It's just math shorthand. So if you see epsilon xy, it's saying sum the xy's. And the order of operation is important. You sum after you've multiplied the xy's. Whatever's in front of the epsilon is what you do first, and then you sum whatever you get. Here, you're supposed to sum x squared, which means you're going to take each of these x's and you're going to square them. And then you're going to get values, and then you're going to sum all those values. So you find by first squaring all the x values and then summing all the square values to get a total. Sum x squared, this is what's in the parentheses first. You're going to sum all your x's, which you would have found up here with sum x, and then you're going to take whatever value you get and square it. So here's sum of x, which gives you 98 if you sum all the x's, and then you're going to square that value. Here, the sum of the x squared is you're going to take the square of 18, which is 324, the square of 6, which is 36, and you're going to take all those squares and you're going to sum them. So you're going to sum all these together to get this value. So it's a different thing. Here you're squaring the sum. Here you're summing the squares. So make sure you're clear on that. Now doing that on 25 is going to be awful. So I'm going to show you how to do it in an Excel sheet. Here's my 10 data points. So I'm going to go ahead and copy those. And by the way, just so you'll know, if you push Control C, that will actually, it copies. You don't have to right click and push copy. I don't do that anymore because sometimes it just messes everything up. If you push Control and then you push V, that's how you paste. So I'll tell you you have to push them down at the same time. So I'm going to go ahead and highlight this. I'm pushing the Control key and now I'm pushing the C key at the same time. That highlights it. And then I'm pushing the Control key and I'm pushing the V key at the same time, and there it pasted it. All right. Now I need to sum these. So to do any operations in Excel, you go up here to your function notation, f of x, and it says, what do you want to do? Well, I want to sum. And actually, you can put sum for everything and then just go in and do whatever you want. You just need to pick an operation. I always just pick sum. So we want to sum. Then the question is, what range do you want to sum from? This has got the right range, D2 to D11. So you choose the range you want to sum from D, and then you push enter and it sums it. This one wants you to sum y, so I'm going to highlight my y's, and I'm going to push Control and the C key, and that copied it. And now I'm going to push Control and the V key, and that pasted it. Once again, I'm going to sum, and in this case, I'm going to sum all these numbers right here, and then I push Enter or push OK, and there it goes. Now I want to sum x squared. So I can't sum x squared until I have x squared. So you always highlight the box your answer is going to be in. So I'm going to put all my x squareds in here. So I'm going to go to f of x. Now, and I'm again, you can just choose sum. It doesn't matter because you can do whatever you want when you're at this step. So what I want to do is I want to take this value and I want to raise it to the second power. And then I'm going to push OK, and you can see over here it's telling you what it's going to get, and that looks right. So 18 squared should be about 324. So you can check to make sure your answer is going to make sense, okay? Then 324, just to show you again, this box, you put the empty box where you want your answer to be, and then you push function, the function which lets you type in a calculation. I want to take this 6, and I want to raise it to the second power. And that's going to give me 36, which is correct. Now, you don't have to do it for both of these. I just did it twice so you could see how it works. At this point in time, all you have to do is this little square here, you just grab it, you put this so it makes a little cross on it, and then you pull down, and it will copy that calculation all the way down. So there's all my values squared. You guys are going to have 25, so you're not going to be wanting to do this with each individual cell. You just want to do it with the first one, grab the little plus sign, and then pull it down, and then it will find all the squares for the rest of them. It copies the formula. Once again, I need a sum for that, so I'm going to go to my function. I'm going to click on sum, and I want to sum from here to here. It's already got the right numbers. I'm just doing this to make sure you understand. You push OK. This wants to sum all my x times y, so once again I need to multiply x and y. So I go to the first cell, function, again, sum, I don't care what it says. What I want to do is I'm going to delete that. What I want to do is I want to take this value, times is your asterisk, that's how you say times, and then I'm going to click on the y, which is my 84. So I clicked on the D2, which is my x, then I'm going to click on the E2, which is my y, and I put an asterisk between them to signify multiplication, and I push enter. There, I got my multiplication. Don't have to do that for every cell. I'm just going to copy the formula on down. Once again, I want to sum. Actually, you could probably, let me see what happens if I pull this over, because I know, yeah, you can actually pull the formula sideways as well. This summation formula, so since I found the sum for the first one, and I'm just summing the same thing, I could actually just do the little box and pull it sideways, and it will give me the sum formula. But I showed you how to do it, but you could actually, once you have a formula that you're copying into multiple cells, you just drag the box and it does it for you. Okay, so I took these answers and I went ahead and I pasted them into the directions here. So there's all those values that I just found. Now, I want you to notice this formula right here. It looks really complicated, but it's not. It's just simply take the sum you got for your y's, which is 753, multiply it, that's what the parentheses means, times the sum you got for your x squared, which is this value. Then you're going to subtract the sum you got for your x's, which is this value, and multiply it times the sum you got for your xy column, which is this value. Okay, so let's go ahead and look at what this looks like. Sum for this was the sum of my x, this was the sum of my y, this was the x squared summed, and this was the x times y summed. So my sum of my y's was 753, I put it in here. The sum of my x squareds was 1396, I put it here. The sum of my x was 98, which goes there, and the sum of my xy was 8190, which goes there. Then if you look at the formula, then you divide by n times sum of x squared minus sum of x, quantity squared. So n was 10. I had 10 points for this example. My sum of all my x's squared was this first column, 98, so I put 9. Oh no, I'm sorry. The sum of all my x's squared. Here's the sum of my x's squared. This is a little confusing. The sum of x squared, if you look here, is 1396. It's this one right here. I need to take the sum of all my x's and square that sum. So I'm not going to be doing that. I'm going to take the sum of my x's, which is 98. If I square 98, I get 1396. So that's where that value came from. Oh, whoops. Is this right? Oh, no, it's right. Never mind. I'm saying this backwards. 1, 2, 3. For the bottom, we need to take the sum of all the x squareds, which we have here, it's 1396, and subtract the sum of all the x's squared. So you're going to take the sum of all the x's, which is 98, square that, and you get 9604, which I've shown here. Here's the sum of all the x's, which is 98, and you have to square that. So that's the difference between this and this. They're not the same, so pay attention. This is the sum of all your x's, and then you square that answer, which is going to give you 98 squared. And then I went ahead and simplified it, and I got 248,568 over 4,356, which gave me a decimal of 5706. And you will want to use a decimal for your y-intercept. To find the b, which is my slope, in my linear regression formula, that b is slope, I'm going to multiply 10 times my sum, the row that I got for the xy's, which is the last one, minus the sum I got from the x and the sum of all my y's, which was the first and second column. And then I'm going to go, which is right here. You can just check your answers right here. Then I'm going to take 10 times the sum of my x squareds, which was this. Those are all my x's squared, and subtract the sum of all my x's, which was 98 squared. When I simplify that, I get 1.86. So my y-intercept is 57, my slope is 1.86. Remember, we write it as y equals a plus bx, just to go back and make sure what I'm doing here. Y equals a plus bx is the formula that we're writing. So I'm going to go over here and actually put that in so that it can be easier to see. So that's my formula. I've got my a and I've got my bx. So let me insert this. So we have y equals a plus bx, which actually leads to y prime equals 57.06 plus 1.86. Okay, if I go ahead and write this in the slope-intercept notation, I can see it can be written as g, which is my grades, is equal to 1.86. That was my slope here attached to the x. I'm calling it a t now because that's the number of tutoring hours over per grade per tutoring hours, and plus 57.06. Comparing that to what I got on my linear regression equation I guessed at, they're almost the same. I mean, I almost landed right on top, which is amazing. That was totally accidental. The chances of that happening are very slim. But, well, I guess I just guessed really good. I picked a line that did look like it went through the middle, and evidently it did. So my actual true trend line regression equation is 1.86t plus 57.06, or the proper way to write it is 57.06 plus 1.86 x, or t. This would be your g and this would be your t. What you need to do now is to redraw the graph with the trend line included. So I'm going to go ahead and copy this graph so I can add the trend line to it. So to copy the graph, you go up here to New Slide, you choose pull down menu, and then choose Duplicate Selected Slide. So it's gone ahead and made that slide. You'll have to change your title to least squares regression line or something like that, okay? Again, let's go ahead and push the plus sign. Now, what you're going to see here is there's your trend line. Okay, so this is what you want to click on because this is going to show you the actual line. I'm going to click off of that. These are the three lines I drew. Now watch that and see where the trend line appears. See, there it is right there. B was what I chose, and B was almost exactly the same as the trend line, and you can see right here B is almost identical. If I go ahead and get rid of these two lines, you can see that my line B was almost exactly the same as the trend line. So that was just like I said, that was a really good guess. I got that. We just found it by hand. There is a way to find the linear regression equation in Excel to actually write it out. So this is the part you need to show in a slide, and then the last slide will be answering the rest of the questions, which ask you to draw the actual least squares regression line, which we've just done. Click on the graph, and when the plus sign appears, check the trend line. And finally, on the last slide, you're going to comment on how close your estimated line of best fit was to the actual trend line, and any other conclusions you came to. Anything else you noticed, just be prepared to explain what's happening when you present this.